Okay, so number 25 asks us, for what value of n will the graph of f of x equals x plus 1 times x plus 2 times x plus 3 times x plus 4 plus n intersect the x-axis in exactly two places? Well, in order to think about that logically, I've drawn the graph of the original function f of x without the n. So just this part. And that looks something like this. And you can determine from problem 23, which was done earlier, that this height is 9/16, and this x value right here is minus 5/2. That is, the local maximum is at minus 5/2, 9/16. Okay, and to think about it, you need to know when when it would intersect the x-axis in only two places. So that's going to be when these minimums, when you shift the graph up so that only the minimums touch the x-axis. And that's kind of hard to figure out here. You can do like we did in 23, where we just averaged these two to find where we think the minimum would be, but it doesn't actually turn out correct. You're off by like 1/16. So what you need to do is shift f so that this maximum rests on the origin. I'll draw that for you. Like this, so that we can find an equation that we put in the form so that it's easy to find these minimums. So how do we do that? Well, let's call the new function g of x. We know that we're going to have to shift f to the right by 5/2. And then we're going to have to subtract 9/16 from it. And you can actually expand this out and do this yourself. It's kind of a lengthy process. So to save time, I'll rewrite g of x, skip a few steps, and simplify it down. X to the fourth minus 5/2 x squared. So that's when you put x minus 5/2 plus 1 in each of those, like x minus 5/2 plus whatever's there in each of those equations. That's what I get. That's what this will simplify down to. And still, this equation doesn't, or this function doesn't really tell us where the minimum would be. So what we're going to do is we're going to complete the square by adding a value to each side so that we can factor this down, and it gives us the minimum in an easier equation. So in order to complete the square, we're going to have to factor this down, right? So we're going to take this coefficient, minus 5/2, multiply by 1/2, and then square it. Get 25/16. So we're going to add 25/16 to both sides of the equation. So we have g of x, or the function, g of x plus 25/16 equals x to the fourth minus 5/2 x squared plus 25/16. But like I said, that's actually going to factor down. And it's going to factor down to x squared minus 5/4 squared. Alright, now we can put this back. G of x equals x squared minus 5/4 squared minus 25/16. So this tells us actually what the minimum value of the function is going to be. It's going to be square root 5/4 minus 25/16, and so on. So these are located at y equals minus 25/16. So for this function, for g of x, in order to shift it up such that only these two minimums intersect the x-axis, we would add 25/16. But remember that this is the transformation. So in order to get back to the original function value, we're going to have to add the 9/16 that we subtracted. Minus 16/16, which is -1. And what that is saying is that these are located at x minus 1, x2 minus 1. So the minimums of this function have a y value of -1. Well, if we want only the minimum values to intersect the x-axis, all we have to do is shift the graph of f up by 1. Since this is already in a good form for that, we know that n, the value that must be added, is 1. So n equals 1 there. Like I said, it's different if you did like -3/2 for that one and then tried to solve. You get 15/16 is the distance you need to shift, and that's not actually right. So you do need to go through the process of shifting the function and then finding completing the square, and then finding the minimum, and then shifting it back, so to speak, and then you get the value of n. So, thank you.